two states. One is lock and unlock. Similarly, when the signal is transmitted in the form of digital or discrete form, so the symbol has two state, either 1 or 0. So that's why in case of digital modulation techniques, all the modulation techniques are termed as keying, amplitude shift keying, frequency shift keying, like that. And there are different types of this is binary modulation. Also there are MAD modulation, that is QPSK, QAM, and different application. It has different application. Okay. And also there is spread spectrum technology that is mostly used in case of military communication and error control coding. So the blue part that is written over here, that is the blue color, that will be, I will discuss that you, this is the my part, and the rest of the part that will be Shontu sir will be your, he will be discussed in the classes. Okay. So the book that follow for your digital communication classes, that will be BP Lati, Simon Higgins. Mostly I will follow the Simon Higgins and the BP Lati, and the some portion of the Oane Tomasi. Okay. So these also be some books, but it is better if we follow the Simon Higgins and some portion of Lati and the Tomasi. So this Tom and Ceiling and Cookies is little bit hard compared to these books. Okay, and the Dust Moldic and Chapels. These are the books. And after the class, I will give the PDF of your today's lecture. Okay, so I will mail you. Now the communication system. This is a introduction class. So just I'll give the familiarization of the communication system. So all of you know communication system is why we are using communication system, because see, I am communicating with you. I am speaking to you. So I'm sending some information. I wish to send some information to you. So how I am sending the information by online classes, by online mode, by means of the communication system. Here we are using the wireless communication system, isn't it? That is the wireless communication system. I am sending the information to you. So I am the source and you are the destination, isn't it? So communications means I am delivering something. I am delivering my lecture to you. So you are listening. So you are the destination. So this thing is deliver. That means communication system is delivering information from source to destination. Through where? Through the physical or logical channel. So physical means there is a wire connection, and logical means that is a wireless. There is no wire, isn't it? So if it is a physical channel, so obviously the signal will be transmitted in the form of electrical, and if it is a your logical channel, that is a wireless channel, so there should be some antenna. Antenna will be radiate the electromagnetic wave, and that electromagnetic wave will also be received at the receiver section of the destination. So there should also be another receiving antenna. So that means if it is a logical channel, so your information should be transmitted in the form of electromagnetic wave, and if it is a physical channel, the information is transmitted in the form of electrical. So that thing is written. Okay. So now the information, how I am transmitting the information? I am speaking the word, that is the speech. I am giving some speech to you. So this is the analog information, isn't it? So frequency is around 4 kilohertz. So that means 0 to 4 kilohertz. The bandwidth of my speech is within the 0 to 4 kilohertz. So this signal when transmitted, so I'm communicating through you. I have a laptop, you have either a laptop or a mobile, but this information is transmitted through the in the form of digital, isn't it? Otherwise, your it is not received by your antenna or the laptop. So that means there is something that is converted. So your computer can receive only the computer data can be received only the digital form of information. So the information may be analog or digital. If it is a analog, so if you use digital communication system, you have to be convert that information in the digital form. So my voice is your that is the analog information. So in between your me and you, there must be something so that it converted into analog to digital form and transmitted to your end. And again, that is also be converted into analog form. Otherwise, what I am saying, you cannot receive that information, cannot hear that information. And also be information maybe image or video or data. Okay. So these are the different types of information we use for the communication system to transmit the information. So what are the basic element in that means if we say the communication system, there must be the three entities. What are the three entities? One is your sender who wish to send the your information. Another is the destination of the receiver who wants to receive the information, and is media or channel which carries your information or the message. This is the basic block diagram of any communication system. But if we transmit the information from the sender and that is receiver will be receive the information. If the distance is short, then it is okay. But for long distance communication, so when the signal is transmitted through the media, so there is a chances of the signal deterioration. So at the receiving end, when the signal reach the level of the signal strength will be such that so receiver cannot recover or cannot listen or cannot your or also we cannot visible or your information. So obviously in between the sender and receiver there must be some manipulation of your information. So some other block should be there to manipulate your information in such a way that when it's transmitted through the channel, when it's propagated through the channel, though there is impairment present in the channel, it cannot, that means totally attenuate your information and the receiver can recover the information. So that's why, so these blocks will be divided into number of blocks: information source, input transducer, transmitter, then channel. Channel is nothing but your media, receiver, and output transducer. What is that means here? What is the information source? That means sender send the information. Suppose I am talking to you. So this is our speech information. Or suppose I want to record the temperature, the whole day temperature, or the pressure of the whole day, or the precipitation of the whole day, and I want to transmit that information to you. So these are the physical parameters. So these physical parameters, how I can transmit to the channel? So before transmission, I have to convert that information either in the electromagnetic form or maybe in the electrical form. So the transducer convert that information, that is non-electrical signal, into electrical signal. So this will be, it may be your sound, maybe your picture or anything that will be converted into electrical form, and the transmitter section manipulate the information. And in this transmitter section, there are also number of elements and that manipulate the information or modify the information and transmit the information to the channel, pass the information to the channel. And within the channel, some noise is mixed. Mostly in case of communication system, for simplicity, we are considering the noise is additive noise. So that's why we are considering always additive white Gaussian noise channel. This term is very important. Sometimes in your interview, this word will also be asked. What type of noise is generally we are considering in case of communication system design? For simplicity, we generally consider additive white Gaussian noise. Why we are considering additive white Gaussian noise? Because noise is added. Your information is this part and this noise is added. This noise may be multiplicative. Okay, but if we use the multiplicative, so obviously your system design will be much more complicated. So that's why for simplicity we are considering that is the additive. And Gaussian noise, we are mostly consider the noise is present within the channel is Gaussian nature. Because that noise is affect the signal of all the frequency in the same way. Okay, so the it's if we consider the other noise, it is not Gaussian, then obviously it will be different frequency, it will be the attenuation amount will be different. So that's why we are considering the Gaussian noise, Gaussian white, Gaussian noise. White in the sense that is noise is affect all the frequency in the same way. That means the same amount of attenuation is that means that is affected by all the frequency component of a signal. A signal contains composite of the frequency. I am saying the speech frequency is 4 kilohertz. Is it meaning that all the frequency is 4 kilohertz? No, the bandwidth is 4 kilohertz. That means the frequency is content is 0 to 4 kilohertz. Sometimes it is low, sometimes it is high, but within the band 4 kilohertz. Okay, so that's why. So all these 4 kilohertz range, all the frequency component, if it is 1 kilohertz, 2 kilohertz, 3 kilohertz, or 2.5 kilohertz. So all the frequency component will be affected same way by means of the Gaussian noise. So at the receiver section, there is also number of elements because in the transmitter section you are modifying the information, you are manipulating the information. Why you are manipulating the information? Because to uh, uh, that means because the signal when it is transmitted through the channel, the signal is attenuated or distorted by means of the noise present in the channel. So that's why you that means protect your information when it's transmitted through the channel by modifying the information in the transmitter section. So that the receiver section, as it is signal, original signal is modified, so receiver section is just a reverse of the transmitter section. It will be recover the actual information and it's passed through the output transducer. Output transducer, the input is electrical and output is your physical parameter. That is the original form of information. Okay. So you know that the communication system that you have already studied in your earlier semester, that is another communication system. In short form, it is called the ACS, and the digital communication system, it is in short form, it is called DCS. So suppose you are designing a communication system. It may be your digital communication system or maybe your another communication system. But your system is good or bad. How can you judge? So by means of some parameter, you have to be judge the system. So what are the parameter that is used to judge the communication system? The parameter that is used to judge the performance of the analog communication system is the fidelity of the received waveform. What is fidelity? Fidelity is nothing but the signal to noise ratio. Or you can say here fidelity means that is in case of analog communication system, when you transmit the signal in the analog form, the important thing how you that means your shape of the information should be that means remain same at the receiver section. That is most important part in case of analog communication system is the when the signal is transmitted through the channel at the receiver section, receiver should receive the information the same shape as it is generated from the transmitter section. So shape of information is very important and that is called the fidelity. Okay, and in case of digital communication system, as we are transmitting the information in the form of bit stream, so for that cases, we are measuring the performance by means of bit error rate, or it is called BER, or sometimes we are call it by probability of bit error. এই তোমরা বুঝতে পারছো তো?
Yes, ma'am.
So these are some milestones in the history of electrical communication, how the digital communication system is originated. First, it is originated in the year of 1838 when the your Morse demonstrated the technique of telegraph. It is the first your telegraph is the first digital communication system started actually in the year of 1838. Then telephone is invented by Alexander Graham Bell. But that time your communication system was very costly communication system. Means if we go for the analog instead of analog communication, go for the digital communication system for transmitting the information, or that is to or receive the information. For that cases, your design of the communication system, that is transmitter section, the receiver section, that is much more complex and also be your costly. So when you are going for designing anything, so you have to be more, that system will be more popular. That means get popularity if it is a cost effective way of design, so the your common people can be use of that system, isn't it? So that is possible after the your invention of that microprocessor and the VLSI. So it will be decreases the cost, so obviously it will be, that is your digital communication is basis popularity. So in the 2000, several new concepts and the standard in the data network such as wireless LAN, WLAN, ad hoc network, personal network, as also the sensor network is nowadays is used. And now it is most of the your system, that means communication system, are converted into digital communication system. So now, what is your bit error rate? How you measure the bit error rate? So bit error rate is generally used for measuring the performance of a digital communication system. This is the parameter. This is the main parameter that is used in case of digital communication system to measure its performance. And you are receiving the bits at the receiver section. Transmitter also be transmitted the bit string. It is transmitted through the channel, and bit string means that is 101010. So due to noise, this 10 maybe flip, maybe 1 is flip into 0 or 0 is flip into 1. So obviously when the receiver receive, so that information is not actually transmitted from the transmitter. It is altered due to the noise presence in the channel. Okay, so the number of the bit error rate is the number of received bit of a data stream over the communication channel that have been altered due to noise or interference or the distortion or any bit synchronization error. Bit synchronization I will be talking later on in the later classes. So this is the how many bits are deteriorated or how many bits is altered due to the channel impairment, due to channel noise or interference. Okay. So that is the bit error rate, is the number of bit error is measured per unit time. Always we are measuring per unit time. So this bit error rate is applicable for any communication system. Nowadays all are digital communication system. So you are transmitting in the form of bit stream. So obviously, so it may be applicable for fiber optic communication, maybe Wi-Fi, cellular communication, or nowadays IoT is used. So obviously, so all these for all application, this bit error rate is applicable to measure the performance of the system, and generally it is the measure by the factor error divided by total number of bits. That means how many bits you are transmitting and how many bits the receiver receives, and out of these bits, how many bits are in error. So if I say that bit error rate generally are considered in the form of 10 to the power minus 4, 10 to the power minus 5, 10 to the power minus 6, 10 to the power minus 7. Suppose it is 10 to the power minus 9. Bit error rate is 10 to the power minus 9. That means out of the bit 1000000000 means 9 zeros. Out of 10 to the power 9 bits, 1 bit is in error. Okay. So out of this number of bits 10 to the power 9 bits, if the receiver receives 10 to the power 9 bits, out of that 1 bit is error, then it is called 10 to the power minus 9. If it is 10 to the power minus 3, that means 10 to the power 3, that means 1000 bits is received by the receiver, and out of that, and that is per unit time, and out of that 1 bit is error. Okay. Then this bit error can be your decrease, or you can say that bit error can be removed from the system by means of error control coding technique. That will be the your Shonku sir will be uh, teach you that portion. So different types of coding techniques are used to recover the bit error rate. So there are different types of coding techniques is used to recover the bit error rate. Source coding, also be channel coding. I am coming that one also. What is source coding? What is channel coding? Different types of coding is used, but source coding is different. Channel coding is different thing. Now, how to improve the bit error rate? There are different types of technique to improve the bit error rate. One is increasing the transmitted signal power. So why the increasing the transmitted signal power? So suppose the receiver received the bit error rate 10 to the power minus 3. That means out of 1000 bits, 1 bit is in error. Okay, and it is so the receiver is your that means the receiver. What is the intention of your transmitter? That is to uh, decrease the bit error rate. So that means it will be 10 to the power minus 4 or 10 to the power minus 5. Okay. So improve the bit error rate. Sorry, not decrease. Improve the bit error rate. That means 10 to the power minus 4 or 10 to the power minus 5 instead of 10 to the power minus 3. So how can you improve? Why the bit error rate is occurred? This is the channel noise. So channel noise is such that the strength of the noise is such that it overcome the strength of the signal. That's why it's mask your information or deteriorated information. Now, if the signal strength of your transmitted signal is increases, so obviously it is not mask. The noise cannot deteriorate the information or cannot deteriorate the strength of the information. So you have to be increase the strength of your information that is you are transmitting from the transmitter section. So that's why transmitter signal power should be increased. But when you are increasing the transmitter signal power, this is the one way. So obviously your power amplifier should be such that can increase the power of your signals, that can increase the signal strength. So if we use the more robust power amplifier, so obviously that will be more costlier design. Or you can increase the strength of your information, or that is the bit error rate performance can be improved by using some filtering circuit. Filtering circuit means in the transmitter section I have said there are a number of blocks are there to modify the information. You know that in the channel I have said already that intersymbol interference is also occurs, and due to that your maybe there is a chances of the bit error rate. So to remove that bit error rate, also some filter is used to resave your symbol Also, some equalization filter also used to remove the noise presence within the channel, and different types of modulation and demodulation, improved modulation and demodulation techniques is also used to improve the that is the bit error performance. And already I have said that the different types of coding and decoding. So this portion I will be teach in later classes, that is filtering circuit, that is equalization to overcome the ISI, also modulation, demodulation. Okay, and this portion will be by the phone user. And how many types of noise is occurs in case of communication system? One is natural noise, another is your man-made noise. Some of your internal noises also be occurs. Internal noises may be generated from the internal circuitry, means your transmitter section, receiver section. Some noise may be generated because there is also electrical component also there, and your thermal noise is also there. Also, some natural noise is also be generated in the channel, like your due to lightning, thundering. Okay, that is also be noise is generated. Also, some external noise is generated, that is called the man-made noise. So, what is that? So, the external noise may be your natural noise or maybe man-made noise. Natural noise means lightning, thundering. This is the natural noise. But the man-made noise, that means suppose they are in your, that means near to your house, there is some industries there, number of electrical motor is running every day, and this may be generate some noise. This may deteriorate your communication system also. Also, high voltage power line noise also there, isn't it? So also some telephone exchange there are number of switching operation are there. This may be generate some noise. So this type of noise is occurs in case of communication system. So in case of digital communication system, that is different from the analog communication system. Some extra blocks are required, and that blocks are specific only for digital communication system. So this is not for the analog communication system, not required. These are the specific blocks that are required in case of digital communication system. What are that specific block? That is your one specific block is your source encoder, another is the channel encoder. So this portion is information source. This transducer is converted into electrical form. But the source encoder and the channel encoder is not required for the analog communication system. Similarly, here also channel decoder and the source decoder. And this is your before your transmission of information through the channel, you are modulating. So your information up to this portion, your information is on baseband, then it will be converted into your passband information. Okay. So, or sorry, bandpass information. And this information will be again demodulation, means it will be converted into again baseband information. That is the original information. So now, what is the function of each block? Already I have said the function of the transducer block, the transmitter section, or in the transmitter part, the transducer function is converted from the physical parameter to electrical form, and the output transducer it converted electrical to physical parameter or original information. That is the recovered information. But in case of your source encoder, see here the information source of the input transducer in digital communication. The signal produced at the source is converted into digital signal consists of 1 and 0. Okay. Now this part, that means your, so this part here there is a sampling, also quantization is like that. So here you are transmitting the information into analog to digital form and also by means of the transducer. After that, pass the information through the source encoder. So already the input of the source encoder, already your information is converted into digital form, number of bit stream. Then what is the purpose of source encoder? It's encode the information in such a way that it's remove the redundancy within the signal. That means, suppose I am transmitting the information comprising of number of bits is 20. One information that I am transmitting that is comprising of bits is 20. And some of the bits, if I remove, it's not deteriorate my information. That means some of the bits is redundant bit. So the purpose of the source encoder is to remove that redundancy. It is compress the information. So the source encoder in digital communication system convert the signal from the source into digital signal. The point to remember that we should like to use a few binary digits as possible to represent the signal. That means for efficient representation, the source output result in a little or no redundancy. Clear? So the purpose of the source encoder is to remove the redundancy. That means it is compressing the information. So out of the 20 bits, I am saying that my information is transmitted by means of 20 bits. That 20 bits is not required. So I am compressing the bits in the form of 15 bits. So 5 bits was redundant and that bits are discarded by means of the source encoder. So source encoding and data compression is, you can say, more or less they are same. Okay. Next is channel encoder. Here what you are doing, you are compressing the information by means of the source encoder. So after the source encoder, there is a channel encoder. In the block, there is a channel encoder. So here, input of the channel encoder getting the information in the compressed form. After the channel encoder, it is modulated and passed through the channel. So where your signal is mostly distorted or mostly affected in the channel region. So before transmit the information through the channel, so you have to be use some technique in such a way that if noise is present, but you can easily recover your information, original information at the receiver section. So that's why channel encoder is used. Channel encoder, the purpose of the channel encoder is to add redundant bit. Source encoder remove the redundant bit, but channel encoder add the redundant bit. How it is add the redundant bit? Suppose your information digit is like that, K. This is the K number of K number of your information bits. I am saying the 15 bits. My information contains 15 bits. That 15 bits is the information bits, that is K. The channel output of the channel encoder, when you are getting the information, that will be not the K bits, that will be the N bits. Now it is converted 15 into suppose 18 bits. So the 3 bits you are adding, that is called the parity digit or parity bit. And this parity bit is used to combat the error. Combat the error that is present in the channel. So when the receiver receives the information, that will be the 18-bit or N number of bits, not the K bits. By means of this parity bit, you have to be recovered if any noise deteriorated due to presence of any noise in the channel, deteriorate your information. So by means of this parity bit, that is called the parity checker at the receiver section. So by means of this parity bit, you can recover the information. That is called the error control coding techniques. Number of coding techniques are used: block code, Hamming code, or convolution code. That are the different types of coding is used for the channel encoder section. And also be at the receiver, obviously there will be the reverse process, because already you are modifying your actual information. So the receiver section, the reverse process is from the parity bit, you have to be extract the original information. And after your redundant bit addition, there should be the modulation. That means you are converting that information into, that means your information is digital information, isn't it? Bit stream. But the channel cannot, that means transmit the information in the form of bit stream. Channel is, on the channel you have to be increase the signal in the form of waveform. Either maybe your pulses or maybe in the some analog waveform. So that conversion is the purpose of this digital modulation, is to convert that bit string into waveform conversion. Okay. So this is the digital modeler, map the binary sequence into signal waveform. Clear? লাইনে আছো তো? ভীষণ বৃষ্টি বৃষ্টি হচ্ছে, আমি বুঝতে পারছি না তোমরা আছো কি।
Yes, ma'am.
হ্যাঁ, মাঝে মাঝে একটু সাড়া দিও। So now your after all the modification at the transmitter section, you are transmitting the information through the channel. It may be physical channel or maybe the wireless channel. So this channel is the we are considering the channel is additive white Gaussian channel. I am not that means read out all these things because all these things already I have discussed. And similarly at the receiver section, as in the transmitter section, the last block was the digital modulator. So obviously first block of the receiver section will be digital demodulator. Here was the channel encoder, the reverse process is channel decoder. Source encoder, so reverse process is source decoder. And same thing. So you have to be recover the information. So obviously there will be digital modulator first, then channel decoder, and after that source decoder. Note the average probability of bit error at the output of the decoder is a measure of performance of the demodulator and decoder combination. That means you are measuring the performance where at the receiver section. By means of what? Because actually receiver will be receive the information, and this information is already passed through the channel. So there is a chances of the error. So the probability of the bit error will be the one parameter that will be measured at the receiver section to measure the performance of the system. Same thing you are already discussed. I am not going into details. Now, when you are designing any communication system, what are the factors that you have to be keep in mind for designing the communication system? For which factor, based on which you are going to design any communication system? It may be your digital or maybe analog communication. It may be for any application area, for your Wi-Fi, for IoT, for your just speech communication system, that is telephone. First thing is your system should be reliable. You are designing a system such that that is first year the reliability of the system is very high, but after few years the reliability system of the is deteriorated. That means the signal strength quality is gets down because number of subscriber is accommodated. So within the channel number of subscriber is added, means congested. Your channel is congested. So obviously there will be number of your interference will be there. So noise is more. So when you are designing a system in suppose in the year of 2020 and you are going to use that system in the 2030, so obviously that time your noise will not be the same. So noise will be much more compared to 2020, isn't it? So obviously you have to be designing a system in such a way that should be gives a long run reliability and also secure system. No one can copy your system. Privacy should be maintained. So you are designing a system in such a way, and the subscriber will transmit the information. There will be large number of crosstalk. So one may hack your information. So that system will not be gets popularity among the common people. So obviously When you are designing in system, these factors should be keep in mind: reliability, security, and efficient system. And the system should not be it should not be complex. If the system is much more complex, so common people cannot be uh, use that system. Nowadays, everyone is using smartphone, isn't it? So from farmer to your industrialist, so all are using smartphone because it is very simpler in implementation, and large number of your applications are there. So system, and you can add large number of application also be there. So flexibility also be there. So for when you are you can, and you have to be design a system in such that that flexible system should be flexible. That means when at the customer end there are number of demand will be come, so you can add some other features there. So that is called the flexibility. So if your system is not flexible, so obviously you cannot add the more features on this system. So these things is very important when you are designing any communication system: flexibility, reliability, security, and the implementation simplicity. So why the we are going all the analog communication system is nowadays obsolete and going for the digital communication system? Why? Because of number of advantage is there in the analog digital communication system compared to analog communication system. That is the, I'm saying already, that demand of the customer is the system should be flexible. That is the digital hardware. If we use the digital system, communication system, the system is much more flexible system. You can add new features there, no problem. So just changing very small amount of changing, you can add the extra features. And it can withstand channel noise and distortion much better as long as channel noise and distortion are within. Because in this case, why the it can withstand channel noise by means of the third point, there is a regenerative repeater. Third point is regenerative repeater. It can withstand channel noise. Digital communication can withstand channel noise by means of regenerative repeater. Repeater means, actually repeater means is an amplifier. You know the amplifier? What is the purpose of amplifier? It's to amplify the signal strength. When it's amplify the signal strength, so when the signal is mixed with the noise, your noise is also be amplified. But if it is a regenerative repeater, this regenerative repeater, it will be amplify the signal and remove the noise. The purpose of the regenerative repeater is to produce the clean signal. Clean means removing the noise. And in digital communication system, within the channel, there are number of repeater stations. And that repeater station are regenerative repeater. Means every station, if there is a noise is mixed up with the signal, that noise is cleaned by the regenerative repeater. So by means of the regenerative repeater, digital communication system can withstand channel noise and the distortion. So this the regenerative repeater prevent accumulation of noise along the path. Along the path means transmission path from sender to the destination, sender to the receiver, that part. So within the media, transmission media, number of repeater station will be there, and for each station, that means long distance communication means there is a high chances of the noise because it's traveling long distance, and within the channel, large number of noise may distort your information. So obviously, if it's distort, each repeater, regenerative repeater station that remove the noise, and at the receiver it generate a clean information signal or clean pulse. Now digital signal can be coded to yield extremely low error rate, high fidelity as well as privacy. This thing is also demand, that is the low error rate, bit error rate by means of coding techniques. I have already said different coding technique is used. And as a privacy or security is very important factor in case of communication system, because it is channel is free, so everywhere every person are using communicating through the channel, so there is a high chances of cross talk, overlapping of information, noise is there, so maybe your information may get uh, hacked by the other user. So obviously this will be the, you have to maintain the privacy, and by means of encryption and decryption in case of digital communication system, so you can maintain the privacy. And easy to multiplex several digital signal efficient. In case of analog signal, you can also be multiplex different signal by means of frequency division multiplexing or wavelength division multiplexing, WDM or FDM, that is the frequency division multiplexing or the wavelength division multiplexing. So, but in case of digital communication system, you are using time division multiplexing. As you are using time division multiplexing, so here the chances of the uh, number of user to multiplex is much more. That is called the code division multiplexing system, or TDMA, time division multiple access system. So there is that means in case of frequency division multiplexing, there is a chances of the more crosstalk, because the total channel is divided into number of small bandwidth, and now each channel bandwidth will be specified to for each user. So that is channel bandwidth is specific for each specific user, assigned to a specific user. But in case of frequency division, time division multiplexing, the total channel bandwidth is free for the, that means for all the user. All the, there is no limit of using the channel. So there was no, that is the channel is not divided between the user. User means how many subscriber are uh, utilize the channel. So obviously for that cases, the crosstalk will be less compared to your frequency division multiplexing techniques. So these are the and also there is number of advantage that the storing of the information in digital form is much more easy. You know that we are storing the information in pen drive, we are storing the information in CD drive. Isn't it? Nowadays CD is also obsolete. Before the CD, we store the information in the floppy disk, and hardly now nowadays all the children they are using the online classes. They even don't even see the floppy disk. Now they are using the pen drive, and sometimes the floppy the CD drive. So obviously the storing is much more easy, because you are storing in the form of, that is the bit stream, not the actual information. It is just a bit stream, and it is the inexpensive way of digital storage. Easy to reproduce digital signal without deterioration of the signal quality, and cost of digital hardware is decreased. I am saying that in 1838, it was unthinkable to uh, use the digital communication system to transmit the information, because the system design was very costly. People cannot think of use that. Though some scientists have used, that is Moses invented, Alexander Graham Bell invented the telephone. So, but the common people is very difficult for using that application, isn't it? Nowadays is everyone is using your mobile phone, because it is a cheap and it is very easy to use. So that's why, so cost is decreasing. Why cost is decreasing? Because your by means of the microprocessor, microcontroller, and VLSI design. So every year the cost is decreasing. So within a very small area, number of integrated circuit you are using, and your it is very handy. So people can be use this thing. So these are the advantages. But when you are going for the all this number of advantage, every system should have some disadvantage also. Okay. If your advantage is more compared to disadvantage, so or you can go for that system. So I am getting that much of the quality of the information, so I can spend some more penny for that, like that. So when that means in case of digital transmission system, you are transmitting the information in the form of bits. That is nothing but the pulse. So bandwidth requirement is much more. You know that a pulse is nothing but the number of combination of the if we convert into frequency domain, that means the pulse, rectangular pulse. If you take the Fourier transformation of the rectangular pulse, we have already studied linear system. What will be the your spectrum for rectangular pulse? That is sync with its extend minus infinity to plus infinity. Am I right?
Yes, ma'am.
Yes, ma'am.
So bandwidth is minus infinity to plus infinity. Very high bandwidth requirement. And in case of digital transmission of the information, you are using 1010. So obviously you are transmitting in the form of electrical pulses. So these pulses of bandwidth is very, very large. Then, but though bandwidth is large, but because of the large number of advantages, so we are going for the digital communication system, and we are discarded by another communication system. So this is very important, mostly in case of your grand viva. Also, if we go for the MTech admission, this type of question asked for based on this electromagnetic spectrum. Also, for any interview, if we go for the communication purpose work, they also be asked this type of question: different electromagnetic spectrum and their frequency range. Okay. So that is the extremely low frequency band is the frequency range is less than 3 kilohertz. Very low frequency 3 to 30. So which is important? Important is the your audio frequency. How much your audio frequency? Sorry, radio RF frequency. RF frequency is 20 hertz to what is your your radio frequency range? Do you have any idea of radio frequency range?
Yes, ma'am.
কত?
এই 3 kilohertz to 300 gigahertz থেকে এখানে দেওয়া হবে।
3 kilohertz to 300 gigahertz.
3 kilohertz না ম্যাম, ওটা 30 kilohertz থেকে 300
Yes.
gigahertz।
Generally this is 30 to your mega. When it is go for your gigahertz, that is your microwave range actually.
হ্যাঁ, microwave।
Okay.
Yes, ma'am.
So medium frequency range is 300 kilohertz to 3 megahertz. High frequency is 3 to 30 megahertz. Mostly
Yes.
this is the radio frequency range. This is called mostly the radio frequency range. And the very high frequency, ultra high frequency, that is the television channel is used. That is 30 hertz to 300 megahertz and also 300 megahertz to 3 gigahertz. And the frequency more than 1 gigahertz is called the microwave range. And this frequency range, that is extremely high frequency, this range is mostly is the experimental stage. Nowadays, this is mostly used for the experimental stages. Okay. So up to this, that means this block, this is for that is used for the wireless internet, radio, TV, cell phone, and all these things. I'm coming in application area. See, AM broadcast. Nowadays, we are not using AM broadcast. We are all are using the FM broadcast. So AM broadcast, when there was a radio or transistor in every home, so that frequency range was 540 kilohertz to 1600 kilohertz. It is commercial audio broadcasting from the radio station. Okay. So that black color box was in every home. I have also seen that thing. I think you have not used that thing. And nowadays we are using the FM radio. So FM radio means here AM broadcast means modulation, use the amplitude modulation. Nowadays it is frequency modulation, and the range is, this thing is very important. This question is asking your interview. 88 megahertz to 100 hertz. This is also the audio transmission, but nowadays it is used FM broadcasting. This is called the FM broadcasting. And our mobile communication two band is used. One is 800 to 900, 806 megahertz to 940 megahertz. This is mobile telephone communication. Another is 1.8 gigahertz to 1.9 gigahertz or 2 gigahertz. So this thing for these two band for the mobile communication. And this ISM band is very, very important for the scientific and the research purpose, because this is unlicensed band. In our lab, in our Rajaraja campus also, we are using all the experiment, that is IoT application. In our lab, we are using some healthcare application, and that is the that is used in the some health monitoring system. That means some patient is monitor their health parameter at home and can transmit the information to the destination, means the hospital lane or the doctor's chamber, by means of the IoT link. And that thing already we have established in our lab. Okay, CS building lab already we have established that thing. And for that cases, we are using that ISM band, industrial, scientific, and the medical band. Okay. So this band is very, very useful for the researcher, for the your, scientist, because this is unlicensed band. Anyone can use. But this band we cannot use. All these are the licensed band. And the wireless local area network is also be used in the unlicensed band. That is 2.4 this band and 5.5. And wideband, that is ultra wideband, 3.7 to 10.5 gigahertz. This is the emerging band. This is for short distance communication. This wireless band will be used because it gives a high data rate, high speed transmission. Actually, this will be used for the high speed transmission. This is very emerging band, and people are using this band. This is also the experimental stage. So these are very important for your interview purpose. And you know that the signal is transmitted through the channel. So the channel is, different types of channel is used. So it may be the twisted pair cable, it may be coaxial cable, or maybe it is wireless channel, maybe waveguide, maybe fiber optics. So if it is a wire channel, so wire channel are different types: coaxial cable, maybe copper wire. For your telephonic communication, the coaxial cable is used. Now it is converted into fiber optic. But before that, it was coaxial cable. And some waveguide is used for the communication. So these are the wire channel, and wireless channel is also be there. So for wire channel and each channel, why we are considering different types of channel? So different types of channel is considering why we are going for the coaxial to fiber optic. Because if we go for the fiber optic channel, so the attenuation is compared to coaxial is less. See here, your frequencies operation is the fiber optic is 10 to the power 14 to 10 to the power 16. And the power loss per kilometer, that means per kilometer power loss is less than 0.5 dB. Whereas if we go for the coaxial cable, so for that cases, your power loss is 1 for 100 kilohertz and 3 megahertz is 4 dB per kilometer. So that means your signal strength is fall very quickly compared to the fiber optic. Also, you can use a high frequency communication by using fiber optic. So for high frequency communication, obviously your data rate will be increases. Okay, so that's why we are changing from the all the telephonic communication channel from coaxial to the fiber optic. And before that, some twisted copper wire also be used. And for that cases, your obviously the frequency operation is compared to coaxial cable is less, and loss is also be more. So here the 100 hertz kilohertz loss is 1, but for twisted copper wire 100 kilohertz loss is 3. So that's why we are going for the higher and higher frequency band, because and the more costlier channel, because to get advantage of the path loss or the attenuation of the signal. Clear? So this
Yes,
thing
ma'am.
was your
Yes, ma'am.
the introduction class. So from the next class will be go for your that is line coding. What is line coding? Line coding is nothing but different types of formatting is used to for communication purpose. And that means you are converting the bit string into waveform and impress on the channel to transmit the information to the channel. Number of line codes are used are there, and what line each line code has some every line code has some desirable properties and their advantage disadvantage where it can be used, that thing will be discussed. Okay. So একটু তোমাদেরকে অ্যাটেন্ডেন্সটা তো নেব, কারণ আমাদের কাছে তো অ্যাটেন্ডেন্স এটা নেই। আমাকে রোল নাম্বার আর নামটা বলবে, আর একজন
ম্যাম,
একজন করে সিরিয়ালি বলো।
আমার
হ্যাঁ বলো।
ম্যাম আমার কাছে নেম লিস্ট আর রোল নাম্বারের লিস্ট আছে, আপনাকে পাঠিয়ে দেবো।
হ্যাঁ নেমলি রোল নাম্বারটা পাঠিয়ে দিও, কিন্তু আজকে যারা আছে তারা একটু
হ্যাঁ
অ্যাটেন্ডেন্সটা
হ্যাঁ,
নিয়ে নিন।
ঠিক আছে ঠিক আছে।